All right, welcome to 5.1 video notes, everybody. We're going to start with solving one-step inequalities today, graphing them, and then writing one from a graph. So we can solve inequalities just like equations, okay? So the variable, just like with an equation, we want the variable to be by itself. So it must be alone, otherwise known as isolated on one side. Okay, we isolate the variable by using inverse operations or opposite operations. And of course, we have to keep it balanced, just like an equation. What you do to one side, you must do to the other side. Now, this is special. I want you to star this, highlight it, something. If you have a highlighter, maybe highlight it would be a great idea. Okay, when you multiply or divide by a negative number, so when you multiply or divide by both sides by a negative number within an equality, you have to flip it. The sign flips directions, which we're going to do some examples below here in a second about that. All right, here we go. So, number one, we're going to first solve, and then we're going to check our answer by substituting a different value in and then graphing it. So first, number one, n plus 5 is less than or equal to 16. So let's solve it like a normal equation. We're going to subtract 5 on both sides, and you're left with n is less than or equal to 11. So now when we check it, we need to rewrite our original inequality. And then now, let's graph it. Before we finish checking, let's graph our answer. So this is n is less than or equal to 11. So I'm going to write my answer 11 on the middle of my graph. It's a closed circle because it's or equal to. 11 is a solution, so that should be closed in. And then now, notice how my variable is on the left, and my arrow is pointing to the left. That means that my graph is going to go to the left because it's any value that's less than or equal to 11. So that should be to the left of 11. Okay, now let's check. Now, we have a value that are going to the left here. So let's find a value that's to the left of 11. Let's try 10. So I'm going to substitute 10 into my inequality. So 10 plus 5 is less than or equal to 16. 10 plus 5 is 15. 15 is less than or equal to 16. Is that true? Yes. So that I know we did it right because it's on my graph. 10 is to the left of 11, and I checked my answer. All right, you try number 2 now. Check your answer and solve. All right, here's my work for number 2. So I added 9 to both sides. You get C is greater than 23. So then I rewrote my inequality. C minus 9 is greater than 14. Then I graphed. It's an open circle at 23 because it's just greater than. It's not or equal to. So it's an open circle. 23 is not a solution to this inequality. And then now my variable is on the left, and my inequality is pointing to the right. So any value greater than 23 is a solution. Now to check my answer, I'm going to substitute a value that's greater than 23. So I picked 25. 25 minus 9 is greater than 14. 25 minus 9 is 16. Is 16 greater than 14? Yes, it is. So that means I know I graphed it right. Okay, good job. You try number 3. All right, here is my answer for number 3. So I divided both sides by 12, and you get G is less than negative 4. I rewrote my original to check. 12G is less than negative 48. Then I graphed it. So I should have an open circle at negative 4 because it's not or equal to. Negative 4 is not a solution. And I graphed it to the left because it's any value that's less than negative 4. And my arrow is pointing to the left. My variable's on the left, so I know I graphed it right. Then now I'm going to plug in a value that's less than negative 5. Less than negative 4. Negative 5 is what I use for G. 12 times negative 5 is negative 60. Is negative 60 less than negative 48? Yes, it is. So I know I graphed it correctly. Good job. All right, we're going to do number 4 together. Notice how my variable is on the right. We need my variable on the left. So we are going to rewrite this. So negative 7G goes on the left. Notice my inequality is eating the 49. So I'm going to rewrite it to where my inequality is still eating the 49. So notice how this is how you rewrite this one. We have to flip the inequality because we're switching the side in which the variable is on. So now we solve, divide both sides by negative 7, but hold on. Look back at what we highlighted. If you multiply or divide both sides by negative, the inequality flips. So it becomes G is greater than or equal to negative 7. Make sure you flip. I'm going to write here flip. Okay, so now let's check. I'm going to rewrite my inequality. 49 is greater than or equal to negative 7g. Okay, but we rewrite this to be negative 7g is less than or equal to 49. Now let's graph it. Close circle, since it's or equal to at negative 7, pointing to the right. So any value greater than or equal to negative 7 is a solution. Now I'm going to plug in a value that's greater than negative 7. So let's do positive 7. So negative 7 times positive 7 is less than or equal to 49. Negative 7 times 7 is negative 49. Is negative 49 less than or equal to 49? Yes, it is, because it's equal to 40. Negative 49 is less than or equal to 49. So this is true. I graphed it correctly. We're all good. All right, you try numbers 5 and 6. All right, here's your work for number 5. I started it for you. Multiply by 3 on both sides. You get P is greater than 27. So over here, I'm going to put an open circle at 27, graphed to the right because it's pointing to the right. And then now we're going to rewrite our inequality so we can check it. P over 3 is greater than 9. Let's check 30. 30 divided by 3 is greater than 9. 30 divided by 3 is 10. Is 10 greater than 9? Yes, so I know I graphed it right. Good. Notice how my x is on the right side. I need to rewrite this. This becomes x plus 19 is less than or equal to 33. I knew how to flip this because we're flipping the sides of my variable. And also, the 33 should be getting eaten by the inequality. And it still is when I rewrote it. Now we subtract 19 on both sides. This becomes x is less than or equal to 14. So I'm going to rewrite, graph it, close circle at 14, pointing to the left. It's x is less than or equal to 14. Rewrite my inequality. All right, guys, here's your work for the check work. So 33 is greater than or equal to x plus 19. You flip it around. You get x plus 19 is less than or equal to 33. Substitute a value that's less than 14. So let's try 10. 10 plus 19 is less than or equal to 33. 29 is less than or equal to 33. Is that true? Yes. So we graphed it correctly. Good job. There will be a part 2 video for the back half of the note sheet. All right, guys. So we're on the back side of 5.1 video notes. Number 7. So now we're not going to check it. So we're just going to be solving and then graphing. So my x on the left side, so I don't have to move anything. How to get rid of multiplication? We divide. We have to divide by the coefficient, which is a negative 7. Divide by negative 7 on both sides. We have to flip it. Good job. Hopefully you remembered that. Since we're dividing both sides by a negative, we have to flip the inequality. So it's x is less than or equal to negative 5. Open or closed circle. It's going to be closed. We'll put negative 5 right in the middle. It's a closed circle pointing left. So any solution that's less than or equal to negative 5 is a solution. Okay, we're going to skip number 8. I want you guys to try number 9. You're going to have to rearrange, move your x to the left side. Okay, I'm going to pause the video and give you an opportunity to try it. Okay, so number 9. So be careful. You're not only moving the x to the left. You have to move everything that's with the x to the left side. So it's x plus 10 is less than or equal to 8. In the beginning, the inequality was eating the 8, so it should still be eating the 8, which it is. Now, subtract 10 on both sides. You get x is less than or equal to negative 2. Open or close circle because it's or equal to. Negative 2 goes in the middle, and it's pointing to the left. So any value, that is less than or equal to negative 2 is a solution. All right, number 10. So we're going to use this number line to write an inequality. We have to pick one of these answers as a solution. So let's look at our graph first. Notice how it's a closed circle. That means it has to be or equal to. So we can go ahead and cross off any of our possible answers that are not or equal to. So this is not a solution, the third one. So now let's check the other one. It's pointing to the left. That means that it should be x is less than or equal to. So if I have an inequality that is not pointing to the left, then it can't be right. So this one can't be it, and this one can't be it. But let's check our answer. 15x is less than or equal to 60. Divide both sides by 15. You get x is less than or equal to 4. And that is correct. So that's how you can use your inequality skills to eliminate possible answers. All right. Number 11. Kevin was asked to place a check mark next to any inequality for which x equals 5 makes the inequality true. Check over his work and correct any mistakes. So he says that if we substitute 5 into these inequalities, they're all correct. Let's try. 25 is less than 5 times 5. So is 25 less than 25? No. So that's wrong. Let's try number 2. 5 minus 3 is less than or equal to 8. 5 minus 3 is 2. Is 2 less than or equal to 8? Yes. So that's correct. Now let's try number 3. 30 is less than or equal to 6 times 5. Is 30 less than or equal to 30? Yes. So number 3 is right, number 2 is right, but number 1 was wrong. Okay. Number 12. Each of the students below made a statement about the inequality 72 is greater than 8x. Which students made a true statement? So let's first rearrange 72 is greater than 8x. We can move 8x to the other side, and it should still be eating the 72. So that's how we can rewrite this. So let's start. Cassie says that you can rewrite the problem to be 8x is greater than 72. So that is not right, because when we rewrite it, it's 8x is less than 72. So Cassie is wrong. Don says the solution will be x is greater than 9. Let's try it. Divide both sides by 8, and you get x is less than 9. So Don is also wrong, because the answer is x is less than 9, not greater than 9. And Josie says 5 is a part of the solution set. So if my inequality is x is less than 9, let's substitute 5 in for x. So is 5 less than 9? Yes. So Josie is correct. All right, you guys should now go do the must-do practice assignment and then complete the mastery check. Good job.